Hello again. Now we're going to talk about simplifying trig expressions. We're going to use basic algebra such as factoring, distributing, even and odd identities, some basic trig identities, so our reciprocal identities, as well as the Pythagorean identities. Okay, so we're going to be looking at different expressions and determining how we can simplify them. Now, this is kind of hard per se because these are expressions and they are not within the context of a problem. So there's no equal to, we're not trying to solve for anything. We are trying to take this big hunk of Play-Doh and mold it into a nice, smooth, easy to deal with, thin rope. Right? You imagine a big chunk of Play-Doh, it's this just big messy blob, and you'd take it and you'd start working with it and you might smooth it and it's pretty easy to roll it out into a rope and then it's much more organized in a sense. All right, so what we're going to be doing is taking these big hunks of Play-Doh and we're going to smooth them out, for lack of a better way to describe it. And as I said, it's not inside the context of a problem. I don't have this equal to 0. So sometimes it's hard to know where to stop. But really what we're focusing on is just using these strategies. So this first example, cosine x times tangent x minus secant x. We need to simplify this, which means we need to make it look simpler. And for this example, we're going to use distribution. So that is cosine x times tangent x and times negative secant x. So we're going to write that out. That's cosine x times tangent x minus cosine x times secant x. So we have a trick that we often use, and when we think about our trig identities, which ones are the easiest for you to think about? And most of you are going to say, well, sine and cosine, those are the easiest. Those are right on my unit circle. They're the most basic of all 6 of my identities. So the trick we use is to rewrite all of these as sine or cosine. Okay, so sine or cosine. And that should be easy because we understand all these relationships. So I have cosine x. Now, tangent x, tangent is equal to sine over cosine. So I'm going to write sine x over cosine x minus cosine x. And secant is 1 over cosine. So this is times 1 over cosine x. So now that I've done that, it should be pretty easy for you guys to see. Cosine over cosine is going to cancel. That first term becomes sine of x. And again, cosine over cosine cancel. So I have sine of x minus, I'm left over with 1. And this is pretty, the simplest we can take it. How do I know it's simpler? Well, we only have sine to a power of 1. There's only one trig term in here. It's written in terms of our easier trig identities, sine or cosine. The constant is 1. All right, let's look at another example. So in this first example, we distributed and we turned everything into sine or cosine. And if you're taking notes, you should say, well, this is something that I want to think about doing. Distribution, rewriting things as sine and cosine. All right, so let's look at another example. For our second example in this video, we have sine squared x times cosine squared x plus sine to the 4th power of x. And again, we need to simplify. So in this situation, we're going to factor. We're going to do the reverse of what we just did in that first piece. we're going to factor. Sometimes things factor as though they are quadratic. In this case, we're going to factor a GCF. So essentially, and I'll write this out, I have sine squared x, cosine squared x. Now, sine to the fourth, something to the fourth power, that's the same as sine squared x times sine squared x. Now, if I look, both my first and second terms, they both have a sine squared. I know they're terms. Terms are separated by plus and minus signs. So I have one term and two terms. And they both have a sine squared x. So I'm going to factor that out into the front, sine squared x. And that leaves me with, I have cosine squared x plus sine squared x. Cosine squared x plus sine squared x is what was left. We're almost done, but at this point, we want to recognize that we know a Pythagorean identity. What is cosine squared x plus sine squared x equal to? And you guys all know that it's equal to 1. So this is the same as sine squared x times 1, and I don't need to write 1, so this is equal to sine squared x. Now, I could continue manipulating this. I could say, well, I know that sine squared is equal to 1 minus cosine squared x. That's also equal. All of these lines are equal here. We're just trying to find the most simple form that we can. Okay, so once it's in the context of a problem and we are proving or solving something and we have that equal sign because we're dealing with an equation as opposed to an expression with no equal sign, then that gives us a little bit more of a clue about where I'm going to be stopping. But right now we're just trying to simplify. All right, let's look at another example. For our third example, we're going to take this expression and simplify it. So I've got negative cosine of negative x divided by cotangent of negative x. All right, so where should we go? Well, I have these negatives inside my argument. So here we might want to use even or odd properties. One thing I know is that cosine is even. So cosine of negative x is cosine x because that was an even property. Tangent is reciprocal to cotangent. Tangent is odd. That means cotangent is odd. So cotangent of negative x would be negative cotangent of positive x. And that's because this is an odd function. So I'm going to simplify this here. So I've still got that negative in front of cosine of negative x, but we know that cosine of negative x is equal to just cosine of x divided by cotangent of negative x is negative cotangent x. Now, negative over negative, that is a positive, so I'm going to rewrite that here. Cosine x over cotangent x. And this may be as simple as we want it, but cotangent, I can rewrite that in terms of sine and cosine. So I have cosine x over cotangent. Now, cotangent can be rewritten in terms of sine and cosine, as I've maybe already said. So cotangent, Well, we know tangent sine over cosine. That means cotangent is cosine x over sine of x. So this is the same if we think about copy, change, flip. Division is multiplication by the reciprocal. This is cosine x times sine x over cosine x. You'll notice now that both my cosines cancel, and this simplifies to positive sine x. All right, so I'm going to do just one more in here, one more basic strategy that we use to simplify. So we have a fourth expression that we want to simplify. 2 cosine squared alpha minus cosine alpha minus 1. What should we do here? There's nothing to distribute. There are no obvious algebraic operations that I should apply. I can't rewrite everything as sine or cosine because we already have cosine. There's no GCF. Well, we have a quadratic term, a linear term, and a constant term. What we might recognize here is that this is in the form of a standard form quadratic, similar to ax squared plus bx plus c. Quadratic, linear, constant. So in this situation, we can factor using the AC method, bottoms up method, or just guess and check. But we're going to factor using a U sub. So what I'm going to do is I'm going to say, I don't like these cosines. They just make it look confusing to me. So I'm going to come over here and say, let U represent or equal cosine of alpha. So now I'm going to rewrite my original expression. So I had a cosine alpha squared or a U squared minus U minus 1. So I used this U substitution to simplify how it looked. At this point, this should be something that you all recognize and see is easy to factor. This is the same as, we'll say 2U and U, and I know I'm going to have both ones there. So we need a negative here and a positive there. So now we have factored this. All right, so I didn't start with U. I need to go back to alpha. So this is the same as 2. U is equal to cosine alpha, so 2 cosine alpha plus 1 times cosine alpha minus 1. And this would be our final answer here. And you may say, well, that doesn't really look simpler. Well, it is if we had it in a rational expression and say there was a denominator here and we could reduce a factor out. All right, so this was a strategy we factored using that AC method, being able to factor a traditional quadratic, and we used U substitution. All right, so we know how to factor quadratic trig expressions. We know how to apply even and odd trig identities. We know how to factor a GCF and use a Pythagorean identity, as well as distributing and rewriting everything as sine and cosine. So in the videos following this, we're going to have a little bit more simplification practice. These are our basic strategies, and in the next video, we're going to use more strategies for each expression that we simplify.